Hi everyone. So in this video, I want to show you how to solve absolute value inequalities. Okay. So I want to go over the steps one step at a time. So when you want to solve absolute value inequality, always the first step is always isolate the absolute value. Okay. We want the absolute value symbol, the two vertical line. Basically, you want the two vertical line to be by itself, usually on the left side of inequalities. So you want to isolate the absolute value, two vertical line. Okay, step two, do you want to rewrite the inequality? So after you isolate the absolute value, okay, you want to rewrite the inequality without the absolute value. Okay, so basically you want to write inequality without the absolute value. Okay, so how do we do this? Okay, so what I want you to know is you want to use one inequality. So when you're given an expression, let's say x minus 5 is, let's say, less than 4, okay, the absolute value is already isolated. You don't have to do that. Step one has already been done. So you want to rewrite this inequality without the absolute value. So you need to drop the absolute value. So when you drop it, okay, you're going to write one inequality like this. The arrow is pointed to the left. Why? Because this inequality is saying that can you find the distance but are less than 4? On the number line, can you find the number that give us a distance less than 4? So if it's 1, 2, 3, 4, 5, 6, and then you have 1, 2, 3, 4. Okay, so on the number line, okay, so where are the number that give us a distance less than 4? If I only look on the right side of 0. So 4 is right here. The number that give us a distance less than 4 are going to be inward, okay? It's going to be 3.5. It cannot be 4 because there's no inline inequality. So it's going to be, let's say 3.5, you want 3, 3.5, 2, and so forth. So you want to include all those numbers right here, okay? So those numbers are less than, right? So are less than 4. And what about the left side of 0? Because there's two sides you might consider, right? You can have a distance less than 4 on the right as well as on the left from 0. So all those numbers up to, but you don't want to include negative 4, empty dot. You don't want to include those numbers. So basically, the number are we being the number for negative 4 and positive 4. Okay. So how do we write these inequalities? Okay. So you want to include all the number that are less than 4 and greater than negative 4. Right? Because those number negative 1 is greater than negative 4, where it's closer from 0 than negative 4 or negative 3 and so forth. So how would you write inequality? So I say always include the negative number, the negative 4 on the left and the positive number on the right. So for less than inequality, okay, I want you to give me one inequalities, okay, one compound inequality, because this inequality is saying that, okay, both number that give us a distance less than 4 are in between negative 4 and positive 4, okay? So that's what I want you to do on the quiz or on the test. So when I give you compound inequality, after isolating inequality with the less than or less than equal to, I want you to rewrite one inequalities. And make sure you include here the number, the lowest number, which is always going to be the negative number, and the number on the right is the highest number. Okay? So I hope it makes sense. But if it does make sense, you're going to do more example, and hopefully it makes sense. Okay. So we want to then, if you use two disjoint inequality for greater than or equal to. Okay. Then you solve for the variable. If I ask you to graph it, yeah, I'm going to show you how to graph anyway in this video. Okay. So let me give you a problem. Remember, you want to isolate the absolute value, step 1. Is the absolute value already being isolated? Yes, the absolute value is all by itself, so I don't need to isolate the absolute value. So now, if you notice, the inequality is less than, okay? So you want to find a number that have a distance, absolute value means a distance from 0. You want to find a number that have a distance of less than 4. So as I explained, if I was supposed to draw a number line, right? So the number that have a distance less than 4, if is going to be between the number 4 and -4, always number right here, okay? So I'm shading this region. So how do I write this so how do I represent Lewis number without the absolute value? Let me show you. So I want you to write x minus 5 like this, and the less than 4. And on the left, you're going to include the -4. Okay? So it's a distance within. It's within, inward. Okay? Greater will be outward, and that's when I want to see two disjoint inequality. For less than, I want to see one inequality like this. Okay? Then the goal is to step 4, we want to solve for the variable. How do we solve for the variable here? Okay, as you can see here, all you have to do is to add 5, y to get x alone. And whatever you do on one side, you have to do that on the left as well as on the right. And then you end up with a new inequality. So it's going to be x is in the middle, and then you have 1 and 9. Okay, so this is saying that for this inequality, so basically for this inequality to be true, okay, for to be less than 4, the x value, the number x needs to be between the number 1 and 9, not including the number 1 and not including the number 9. So if you were to graph this, okay, I'm going to graph the number line. Okay, I have 1 and 9. So I don't want to include the number 1 because there's no line dot inequality. X cannot be equal to 9, neither to 1. Okay, so it's going to be open dot. We don't include those numbers. Okay, 1, 2. Then because since this one needs to be less than, it has to be inward. So it's going to be always number within. So I'm going to shade V. Okay. That's it. So those are the solutions. Okay. And if you don't believe me, okay, let's pick one. Okay. If I choose 1, let's plug 1 into the inequality. So I have 1 minus 5 is less than 4. Okay. So now 1 minus 5 is 4. So absolute value of 4 is less than 4. So you know that the absolute value of a positive number is 4. Okay. So now let's read this inequality. Is 4 less than 4? No, right? 4 is not less than 4. It's equal to itself, to 4. So this is not true. It's false. So this inequality is not true. Okay, that's why 1 is not the solution to this inequality. Okay, that's why you have an open dot at 1, and it's going to be the same for 9. But if you pick any other pair, any point, sorry, here, any x value. So let's say you choose 5. So this is 1, 2, so 0, 1, 2, 3, 4, 5. Is it going to make this inequality true? Let's see. So 5 minus 5 less than 4. So this we are 0. So absolute value of 0 is 0. Is 0 less than 4? Is this inequality true? Yes, it's true. Why? Because 0 is less than 4. That's true. So that's why we say that any number within this domain, okay, this interval, we make this inequality true. Any number away from it, if you choose -2 or 10, we make this inequality not true. And if you don't believe me, try. Take -1 or -2, plug in, and see if the inequality is going to be true or false. Okay. So again, what I want you to remember here, okay, when you have less than, okay, I want you to give me write one inequality, okay, with like this, okay. So one inequality that includes 2 less than inequality. Okay? I don't know if I make sense. I want to see 2 inequality when you drop the absolute value, okay. So make sure you follow the steps here to help you. Make sure you have your step down. If not, I'm going to do a couple examples like this. So I believe that practice makes progress. So thank you for listening. Have a beautiful day, and see you until the next video. Bye-bye.